This is Algebra Lesson 3-2, Solving Inequalities Using Addition and Subtraction. Equivalent inequalities are inequalities with the same solution. For example, x plus 4 is less than 7 and x is less than 3 is the same inequality. One is solved and one is not. Now, just as you use the properties of equality to solve equations, you can use the properties of inequality to solve inequalities. The addition and subtraction properties of inequalities are just like the addition and subtraction properties for equations. If you add the same number to both sides of the equation or the inequality does not change. If you subtract the same number from the inequality, from both sides of the inequality, then the inequality does not change. Knowing that, you can use the addition and subtraction rules of inequalities to solve them. So in my first inequality here, I have p minus 4 is less than 1. To solve this, I need to get rid of the subtracting of 4. So I do that by adding 4 to both sides. So p minus 4 plus 4, those cancel out, leaving me with p is less than 5. And of course, we also want to make sure that we also graph these as well, because it said to graph them. So if I was to graph this on my graph, I am going to draw my number line. And it doesn't have to be a perfect number line. I kind of like -5, 0, 5. That's all I really need. I don't need to count by ones, but just make it be consistent. You can't have -5 on the right and 5 on the left. They have to be, because we read a number line, it goes from smaller to bigger. The smaller numbers are on the left-hand side and the bigger numbers are on the right-hand side. So p is less than 5. I need an open circle at 5 and a line that goes off to my left. So this is the answer. This is the graph, and now I need to check it. And you might say, how do you check an inequality? Actually, fairly simple. If p is less than 5, pick a number that is less than 5, substitute it back into your inequality, and make sure it makes a true statement. So I'm going to choose a number like 3, because 3 is definitely less than 5. So if I have 3 minus 4 is less than 1, well, -1 is less than 1, so that is true. So that checks my inequality. So p is less than 5 seems to be a reasonable answer. Let's look at number 2 here. 8 is greater than or equal to d minus 2. So to get d by itself, I will add 2 to both sides of the equation. 8 plus 2 is 10. 10 is greater than or equal to d because these cancel out. I like to rewrite my inequality, so d is less than or equal to 10 because that makes it easier to graph. If you do not rewrite them, there's a higher likelihood you're going to graph it incorrectly. Here, I'm not going to put any negative numbers at all. I'm going to have a 0 here. I'm going to have a 5 here. I'm going to have a 10 here. It is a closed circle at 10 and a line that goes to the left. Again, I need to check it. So I need a number that is less than or equal to 10. I'm going to actually choose 10 just to show you what happens if I check 10 into my inequality. I have 8 is greater than or equal to 10 minus 2. 8 is greater than or equal to 8. That is true because 8 is equal to 8. So that also works. So I must have solved my inequality correctly here. So there's my inequality. And I never box my graphs. I just leave them right underneath my solutions. Number 3, c plus 4 is greater than 7. So we'll subtract 4 from both sides. We have c is greater than 7 minus 4 is 3. So c is greater than 3. If I wanted to graph this, I'll have -5, 0, 5. I'm going to put my 1s in there just because I want to make sure that I'm at 3. So 1, 2, 3. I need an open circle. Make sure it looks open, and a line that goes to the right because it points to the right this time. Greater than goes to the right. And again, I should check it. So I need a number that's greater than 3. I'm going to choose 10. So 10 plus 4 is greater than 7. 14 is greater than 7. That is true. So that must work. Now we'll go down to number 4 here. Oh no, it's got fractions. Don't freak out because you have fractions. Fractions are good. It's okay, you can graph fractions. They're not hard to graph either. Don't get freaked out, they're just numbers. All right, so -3/4 plus x is greater than or equal to 3/4. So I'm going to add 3/4 to get this all by its little lonesome. If I do something on one side of the inequality, I have to do the exact same thing to the other side of the inequality, or the teeter-totter is not balanced. So here we get x is greater than or equal to 3 plus 3 is 6/4, which I'm going to reduce because it should be reduced. So I'm going to give myself some more space down here. So I have x is greater than or equal to 3/2. Or you could put x is greater than or equal to 1.5. I do not care if you leave it as an improper fraction or a mixed number. Either one works. I'm going to graph this now. So let's see here. If this is 0, this is 1, this is 2. So 1.5 would be halfway between 1 and 2. It is a closed circle halfway between and a line that goes to the right. So there's my graph. Now I should check. All right, so I'm going to check. I need a number that's greater than or equal to 1.5, so let's choose 2. So negative 3/4 plus 2 is greater than or equal to 3/4. Okay, well, just remember, negative 3/4. If I put 2 in fourths, that's going to be 8/4 plus 8/4 is greater than or equal to 3/4. Well, negative 3 plus 8 is 5/4, which is definitely greater than or equal to 3/4, so that works. Let's take a look at number 5. Number 5, z minus 27 is less than negative 29. So add 27 to both sides. Z is less than negative 2. Make sure you pay attention to your positive and negative signs. So I'm going to graph this. Oh, let's go with 0 here, and positive 2 here, negative 2 there. All right, so it's less than negative 2, so it's an open circle at negative 2 with a line that goes to the left. And again, I should check it. I'm going to check it underneath this time. A number that's less than negative 2, let's go with negative 5. So negative 5 minus 27 is less than negative 29. Well, 27 plus 5 is negative 32. Negative 32 is definitely less than negative 29 because it's worked to the left on the number line. So that is true. Number 6. 6 is less than y plus or y minus 3. To get y by itself, I will add 3 to both sides. 6 plus 3 is 9. 9 is less than y because these cancel out. So all I have to do is I can rewrite this. Y is greater than 9 because it points to the 9 and it's open toward the y. That way when I go to graph this, this will be the right direction. I'm going to go 0 here, 5, 10. 9 should be right in front of 10, so it's greater than 9, so I'm going to put an open circle at 9 and a line that goes to the right. And of course, last time I need to check this, so I need a number greater than 9. Let's go with 10. So 6 is greater than 10 minus 3, so excuse me, 6 is less than 6 is less than 7. That is true. So y is greater than 9 works. All right, other things we need to pay attention to when we work with inequalities is being able to write an inequality from a word problem. So let's say you have a baseball team. Your baseball team has a goal to collect at least 160 blankets for a homeless shelter. Team members brought 42 blankets on Monday and 65 blankets on Wednesday. Write an inequality to describe how many blankets the team must donate on Friday to make or exceed their goal. Okay. So first of all, we need to define our variable, and that's always dependent upon our question. So we need to describe how many blankets the team must donate on Friday. Okay, so first thing I'm going to do is I'm going to let X be the number of blankets still needed. Or the number of blankets donated on Friday, it doesn't matter. As long as you understand that you still need more blankets. Okay, so the number of blankets that that your team already provided, okay, the number provided already plus the number you still need needs to make or exceed, needs to be greater than or equal to 160. Okay, so the number that's provided already, well, they brought in 42 on Monday, plus 65 on Wednesday, plus the number that's still needed, that would be x. Okay, to make or exceed. Exceed means greater than, make means equal to. So that's why it's a greater than or equal to 160. So let's simplify this. 42 plus 65 is 107. So 107 plus x is greater than or equal to 160. To solve this, subtract 107 from both sides. So this would cancel. X has got to be greater than or equal to. If you take 160 and subtract 107, you get 53. So your team still needs to bring in at least 53 blankets, or they need to bring in 53 blankets or more. It doesn't matter how you want to say it. Okay? So remember, it's a word problem, so we have to write it in a complete sentence. So the team still needs to bring in at least 53 blankets. And you're done with that problem. Okay, so we defined our variable. This is where your points would come from. You defined your variable, you wrote your inequality, you solved your inequality, and then you answered your inequality in a complete sentence. All of those are very, very important. Next word problem. The hard drive on your computer has a capacity of 250 gigabytes. You use 115 gigabytes. You want to save some home videos on your hard drive. What are the possible sizes of the home video collection you can save? And videos take up a lot of space. Same with pictures. All right, so first things first, we have to figure out what in the world we were asked to find. And we want to know what are the possible sizes of home videos. Okay, so I'm going to let x equal the possible sizes. So x equals possible sizes. Okay, so the amount I've used, the amount already used, plus the amount I want for my videos, has got to be less than or equal to 250 gigabytes, because that's all my computer holds. All right, so the amount I used already, 115, plus the amount I want to use for my videos is x is less than or equal to 250. So there's my inequality. I'm just going to solve it now. So I subtract 115, subtract 115. These will cancel. X is less than or equal to 250 minus 115 is 135. So I can upload, or you can upload, 135 gigabytes of videos or less. So my video collection can have 135 gigabytes or less. Or I can have at most 135 gigabytes. Okay, and it doesn't really matter how you write it in words as long as everybody understands that you could have 135 gigabytes or less. You could actually even write it that way. All right, your closure question for this lesson. What is the general rule for properties of equations or inequalities? Remember the teeter-totter, that will help you. So what is the general rule for properties of equations or inequalities?